says when the altitude is drawn to the hypotenuse of the right triangle. When the altitude is drawn to the hypotenuse of the right triangle. So you have to meet that condition. If it's not a right triangle, you can't do this. Okay? If we're not drawing to the hypotenuse of the overall right triangle, you cannot do this. You have to meet that. You know, it says when. Maybe it should say if. You know that if then statement, that's what we have to meet, right? Okay? It says the length of the altitude is the geometric mean. Well, the altitude, what would you call the altitude here? What letters are the altitude? Yeah, dB. Okay? Saying that altitude is the geometric mean. So dB should go there, and it should go there. Okay? Now it says between the segments of the hypotenuse. Do you guys agree that that's a segment of the overall triangle's hypotenuse? It's across from the right angle, right? So AB can go there, and the other segment of the hypotenuse would be that one there. This is BC. So that's going to go in the final spot. Okay. And that's exactly the proportion that came from what I was showing you in GeoGebra. Okay. And it's always going to exist no matter what right triangle you deal with, as long as you draw that altitude from the right angle to the hypotenuse. Okay. And if you look at that dB in the location of the means, is that exactly what we said it should be? It should be the same thing, right? Geometric means need to be the same thing in those spots, and dB is the same thing as dB. Okay. When I look at that, this is just kind of a learning thing, I guess, or a recognition thing. Do you guys see if I can select them. You kind of see that T, right? Does that make sense? Upside down T. All right. I try to look for that. Every time I'm doing one of these problems, I try to look for that because those are the components that go into the proportion. All right. So I want to go back to the question that we saw on Wednesday. And it said that this distance was 16. This was 16. That one was y. And the altitude was 12. And we had to go through the setup of all the ratios, all 9 ratios, to really decipher what the best way to solve for y was. But now with this corollary, we don't have to do that. Because we know there is going to be a ratio, or a proportion, that's going to compare the 12. Okay, it's going to compare the altitude so that it goes in those two spots, right? 12 and 12 go in those two spots. That's the geometric mean, correct? Now, what should I put here? I can put one of these, can't I? I put 16 there. It's part of the hypotenuse. And can I put this other part of that hypotenuse? And the other spot. Could those flip-flop? Yeah. Can these flip-flop? Yeah, but it doesn't give you anything new, right? So when I cross-multiply, I get 16y is equal to 144. Divide by 16. Y becomes 9. And that is such a faster way of finding that measurement BC, or Y, than what we had to go through. If you were kind of sit through your notes, you go back and watch the video of that lecture the other day. And practically it was about 20, 25 minutes. And, we had a discussion and I lectured about it, talked about it. But if you're sitting at home all by yourself, that might take 5, 6, 7 minutes. Okay, to write out everything that you need to be able to make the right comparisons. Here it took maybe a minute, okay, at the most. Okay. So those are, I think that's a great benefit. We saw how one problem can be very, very tedious and time-consuming and hard to deal with. Then we get a theorem or a corollary, and it simplifies it really fast, right? It simplifies the process. And that's the benefit of theorems, and knowing them and learning them, is because they're going to allow to expedite processes, okay? Make them go a lot faster. And if you don't know them, then you're a person that has to go back, and every time you see one of these problems, you got to do this. And that's a pain in the butt. Okay. So let's do another example. Okay. I want you guys to take a minute and see what you can come up with for this one. right, so what is the altitude here? What's the geometric mean? Bx, right? It needs to go there and there. Okay? That altitude, that length, the altitude that's on the interior of your triangle is always going to be in those two spots. Now, the two components that make up your hypotenuse are RS and SQ, right? So I get 14. So hopefully you guys are seeing that kind of that T I talked about when you look at that shape and fill in the parts that you know. If I cross multiply, kind of doing it both ways that we talked about earlier, x squared equals 42. X is going to equal square root of 42, right? Now the question is, does that simplify? We always got to check. If it's a composite number, okay, composite meaning that there are prime numbers, that multiple prime numbers that multiply together to get it to me, right? It divides by things other than 1 in itself. And 42 does that. So I'm going to take radical 42 and try to break it down to, maybe 2 and 21. And then take 21, go down to 3 and 7. And now those are prime, right? 2, 3, and 7 are prime. If I take 2 times 3, do I get a perfect square? No. If I take 2 times 7, do I get a perfect square? What about 3 times 7? Is that a perfect square? No. Okay? The only time I'll get a perfect square is if there's a 2 times a 2, right? Or if there's a 3 times a 3, or a 7 times a 7. So I don't have any pairs here that can create perfect squares. So what's that telling me? They all get multiplied back together and put underneath the radical. So x equals radical 42 is actually an already simplified. It's as small as it can get in regards to reducing it. Okay. Now here's my thought. Okay, just kind of work with me here. If I've got 3, because I want to check that, right? So we had x squared is equal to 3 times 14. Now I made that 42, but what if I do it this way? 3 times 14, and we know then that we can write it this way, right? Now 3 is already prime, correct? And 14 is a little bit easier to either break down using factoring of 2 and 7 than maybe 42 was. But I can also do it this way. What's half of 14? 7. What's the only perfect square that's less than 7? 4. Does 4 divide 14? No. So it tells me that 3 is already reduced as far as we go. 14 is already reduced as far as we go. Neither of those, when I multiply them together, are going to develop the perfect square. So then I just combine them. And I combine it for multiplication and get 42. And the more that you do that kind of stuff and recognize that and visualize that, it's almost, I realize I've been doing it since I've been in your seats, but it's instantaneous that you can see those things, you can visualize those things because you deal with it all the time. But if you refuse to do that, your person says, I'm always going to grab my calculator, or I'm going to go online, I'm going to type in, radical solver or radical calculator online and type or symbol lab or whatever, and navigate around the procedure, you're never going to get good at it, and you're going to miss a lot of points in this class because of it. Okay? Please learn that process. All right. I got one more for you. All right, and we'll kind of, I'm not going to read it to you. I'll just give you the picture here. The question overall is asking, can we find the height of this train from the train to the top or to the bottom of the sidewalk? Okay. And this guy is creating a right triangle. It walks you through, like he's using a carpenter square to do this. This is something you could do, but it's asking for that height. Okay. Do you know, does this triangle look very similar to the last triangle we dealt with? It's a right triangle. What is this segment right here called? That's your altitude, right? Do you know how long it is? All right, 8.75 feet. So the reason I gave you this is so that you can transfer values. Learn to do that, okay? You have a parallelogram down here, right? Okay. The assumption is that our feet are perpendicular to the ground. This line is perpendicular to the ground. You got a right angle there, so this gives you a rectangle. So you can transfer those distances. What would this distance right here be? 5.5. Okay. Do you know this distance here? No. So what should you let it be? X. Okay. When we set up our proportion here, because this is an altitude, so 8.75 and 8.75, right? Okay, that's the geometric mean. Now, what can go here? 5.5, and what can go here? X. Okay. So you're going to get 5.5 x is equal to 8.75 squared. And we go ahead and solve that, and it's going to give me x to be 8.75 squared, and then we'll divide that by 5.5, right? Gives me x to be 13.92. Now, I was jotting some stuff over on the side here. On an end-of-course exam, on the ACT, on tests that I write for the rest of the year, you might see multiple choice questions, right? And option A here is 13.92. And you just develop that number, right? And a lot of people are going to say, well, I got 13.92 on calculator. I'm going to glance over here, and I saw the 13.92. I know I'm right. I'm going to circle A. But am I right? No, because I didn't answer the question, right? We solve for x, and that's the algebra kind of that's been programmed in our mind since last year, that when you solve for x, you found your answer. In this question, you solve for x, you found that distance there, right? We want that entire purple distance, correct? So what do I need to do with that 13.92? Add 5.5. And there's my 19.42 that I really should have. Okay? What I want you guys to understand, I think it's important for you to be successful in tests, is to understand how people write them. Okay? When I'm writing a multiple choice test, and you know, the authors of the end-of-course exams, the authors of ACT do this, I'm going to go through the problem, develop the problem, write it out, and I'm going to solve it the right way. I'm going to get an answer, right? And I'm going to plug that into A, B, C, or D. I plugged it into C. Then I'm going to go through and we'll do the problem 3 more times. But each one of those times, I'm going to make one of the most common errors that a high school student would make. Does that make sense? And I'm going to calculate and come up with an answer. And then those answers go in the remaining spots. So that if you're going through things and you're trying to guess and see, maybe you forget how to do something, and you try to navigate through, you might get one of those answers, right? But you're only going to get the right answer if you know 100% what you're doing. Okay? So kind of keep that in mind as you're, and I think when you're in like the 3rd grade, 4th grade, you get multiple choice. A lot of times they would give you the right answer, and all the other ones were just garbage, right? Ridiculous, okay? You've seen me do that on maybe some tests already where I think one of them I put like onions was the option, right? That's not the answer, okay? But that's something that was built into you that you can maybe look at the questions or the options and start picking things out. The harder the tests get, the more advanced the tests get, the less they do that, all right? And that's how they create those answers. Yeah, no.
When it says like 5 feet and 6 inches, you just use like a 5.5 or something like that.
Okay, so yeah, when we see, so in this case, that 5.5 feet is talking about 5 feet 6 inches, because 0.5 is now out of 12, right? 4 inches. We'll get into that stuff and talk about that later on. Don't concern yourself too much about that right now. That's a good question. Guys, there's an assignment on Math Excel. It's 15 questions. It's not going to take you long. Okay. I had several people. I think 4th period had quite a bit more time than you guys for some reason. They had about 10 minutes and they finished it. Okay. The last question is going to ask you to factor though. Okay. So as you're doing that, remind yourself that there is a factoring process, and if you don't end up with anything that you had to factor, you've done it wrong. Okay. We'll talk about that on Monday. Have a great week.